In this lesson, we're going to take a look at some additional OSPF features I like to call nerd knobs. We won't cover all the OSPF features that you could customize in your environment, but just to raise your interest, in this lesson, we will cover the router ID command and the use of BFD, bidirectional forwarding detection. The OSPF router ID is how we are identified to our neighbors. This identification is carried in our OSPF packets and helps in building details into the OSPF link state database. The OSPF router ID is unique for each router. When we enable OSPF on our Arista switch, it will use one of the following methods to determine the OSPF router ID: the router ID command, or if there is a loopback interface configured, it would choose that IP address. And lastly, it'll pick the highest IP address configured on the switch interfaces. Some would say that it's considered best practice to manually set the router ID. To do that, we go into router OSPF configuration mode. So here on switch 4, let's first issue the command show IP interface brief to see our layer 3 interfaces. And I want to look specifically at loopback 0. So I have loopback 0 configured as 172.16.0.4. Now config, enter, router OSPF 1, enter, and then our command here is router-ID. You can put in a question mark and see that it's asking for the OSPF router ID and IP address format. So that's going to be 172.16.0.4. Enter. And then we can verify our configuration with show run section router OSPF. Enter. And right there at the top of the output, we can see our router ID configured. Another useful feature to tie into our OSPF configuration is BFD, or bidirectional forwarding detection. BFD is an industry standard defined in RFC 5880 of 2010, and it was updated by RFC 7419 in 2014. The purpose of BFD is to run a keep alive with neighbors to verify IP reachability. While it's true that each routing protocol has its own keep alive mechanism, BFD is helpful in that we can often dial down the timers to be much more aggressive than we might use within a specific routing protocol. BFD can run on interfaces to detect availability of assets that may be several hops away, such as the case with integration to VMware's NSX. Another good use case for BFD is when you're running a routing protocol with the service provider, for example, external BGP. Your BGP session to the service provider may not be a direct link, and therefore a link failure may take some time for BGP to detect. By running BFD on the relationship to the service provider, you gain the ability to detect failures much faster. On Arista switches, the default transmission rate of BFD packets is 300 milliseconds, and the minimum receive rate is also 300 milliseconds, with the default multiplier of 3. The multiplier is essentially our dead timer. The default multiplier of 3 indicates that we can miss up to 3 successive BFD packets from the BFD neighbor before we mark that neighbor as down. As you can see by the defaults, BFD runs much more aggressively than the timers of our routing protocols, and this helps us to determine failure faster and inform the routing protocol subscribed to the BFD information that a neighbor failure has been detected, and to take appropriate action to route around the failure if another path is available. You can see the status of your BFD neighbors with the show BFD neighbor and the show BFD neighbor detail commands. Let's enable BFD and then configure OSPF to use it on a couple of our interfaces. We'll use the connection between switch 4 and switch 5. So here on switch 4, if we issue the command show run interface Ethernet 5, we can see that we don't have BFD enabled. Interface Ethernet 5, enter, and then BFD space question mark. And we have the echo function as well as the interval. Let's set our interval. If we type interval question mark, we can see our rate is in milliseconds between 50 and 60,000. So here let's use 200 space and then another question mark, and we see where we can set the expected minimum incoming rate in milliseconds from the BFD neighbor. Min underscore RX question mark, and a rate in milliseconds again between 50 and 60,000. Let's type 200 again, followed by another question mark And now we see our multiplier option. Multiplier, space, question mark, and then we have a range from 3 to 50. Just use 3 here and hit enter. And then while we're in interface configuration mode, we'll also tell OSPF to subscribe to the BFD information. IP OSPF BFD, enter. So now we issue the command show run interface Ethernet 5, enter. And we can see our BFD interval of 200 milliseconds with the minimum receive interval of 200 milliseconds and a multiplier of 3. And then we also see our IP OSPF BFD. And now let's do that on switch 5. Get out of configuration mode, exit the switch, jump over to switch 5. And here we're going to be looking at show run interface Ethernet 4. We can see that we do not have BFD configured. Config, enter, interface Ethernet 4, enter, and then the same command we used on switch 4. BFD space interval space 200 space min underscore receive or RX, another 200, and then our multiplier of 3. Enter, and then configure OSPF to subscribe to the BFD information. IP OSPF BFD, enter. As always, let's check our configuration, show run interface Ethernet 4. And now we see our BFD config as well as IP OSPF BFD. Now let's check on the status of our BFD neighbors. Show BFD neighbor, enter. And we can see our destination address, the interface that we're using, the last time it was up, and the last time if it was down, and then the actual state, which is currently up. And we can check that on router 4 as well. Jump back over to 4, show BFD neighbor, enter. And again, the destination address, the interface last up, last down, and the current state of up. And then there's also the option for detail. Show BFD neighbors detail, enter. And here we see a nice output with a little more information that was available in just simply the show BFD neighbor command. And that concludes our lesson of looking at some other options associated with OSPF on our Arista switches.